Hey, what's up everyone? In this video, we're going to solve integrals using trigonometric substitution. So there are three formulas that you need to know. So when you see something like this, when you see that there is a square root of a squared minus x squared in your integral, you're going to let x equal to a times sine of theta. And don't worry, I'm going to show you plenty of examples. If you see the square root of a squared plus x squared, then use x equals a times the tangent of theta. And the last one is the square root of x squared minus a squared. In this case, you have to use x equals a times secant of theta. So let's say we're using the first form. Well, our assumption is that theta is between negative pi over 2 to positive pi over 2, and so on. But don't worry too much about this. These are the ones that you need to know. Our first example will be the integral of the square root of 9 minus x squared over x squared dx. So right away, we see that we have 9 minus x squared. And 9 minus x squared is the same as 3 to the power of 2 minus x to the power of 2. So which form do we have? Is it the first one, second one, or third one? Well, you guessed it, it is going to be the first one, and you can see that a is equal to 3. So our formula will be x equals a times sine. So x equals a, which is 3, times sine of theta. And we also need to find the derivative. So the derivative dx over d theta, what is the derivative of 3 of sine? Well, it's going to be 3 times cosine. And what we can do is multiply both sides with d theta. So let's do that. And we end up with dx equals 3 cosine d theta. So we have the integral of 9 minus x squared. And x is 3 sine. So 3 sine to the power of 2 over x squared. So the same thing. 3 sine to the power of 2. And don't forget the dx. This is very important. So dx is equal to 3 cosine d theta. So 3 cosine d theta. I'm going to put x equals 3 sine up here because this is something that we will reuse later on. Now, what is 3 sine to the power of 2? Well, it's going to be 9 times sine of theta to the power of 2. So 9 of sine theta to the power of 2. Now let's simplify the numerator as well. So we get 9 minus, and this will give us 9 sine of theta to the power of 2. And we need to factor out the 9. So we get the square root of 9 times 1 minus sine of theta to the power of 2. Now we can still keep simplifying this using our trigonometry identities that you might have learned in high school. So those ones are cosine of x, and this is to the power of 2, plus sine of x to the power of 2 is equal to 1. You also have tan of x to the power of 2 plus 1 is equal to secant of x to the power of 2. And the last one is cotangent of x squared plus 1 is equal to cosecant of x to the power of 2. Now let's take a look at this one. If you subtract sine x squared on both sides, let's do that. You will get cosine of x squared is equal to 1 minus sine of x squared. So we need to replace this part with cosine of x squared. And notice that we are using theta instead of x because we have been using theta all along. So here we have to use theta. And what is the square root of 9 times cosine to the power of 2? Well, that one is easy. That's going to be 3 times cosine. So let's replace the numerator with this one. Let's go ahead and multiply 3 cosine with 3 cosine over here. So we will get 9 cosine to the power of 2. And here the 9 and this 9 will cancel out. So what is this going to be? We know that tan is equal to sine over cosine. How about cotangent? Well, cotangent is 1 over tan. This is the same as 1 over sine over cosine, which is the same as cosine over sine. So here we have cosine to the power of 2 over sine to the power of 2, and this whole thing is equal to cotangent to the power of 2. So how can we solve the integral of cotangent to the power of 2? Let me show you an easy trick. So you can see here this diagram, we have secant of x and this arrow to secant of x and this arrow pointing backwards with the 2, then tan of x, and the same thing over here. The difference here is we have cosecant of x points to negative cosecant of x, and then we have this same arrow and then cotangent of x. So how can we use this diagram? Well, let me show you. So the derivative of tan of x is equal to what? We see this arrow, right? So we have secant of x, and then we have to the power of 2. And we go this way, right? And then we get blocked up by this arrow. So that's kind of the way that I do it. When I look at tan, then I see secant of x. So that's how I get this one. And similarly, how about d over dx of cotangent of x? Well, same thing. I look here, then I go over here, then I see cosecant. So negative cosecant actually. And then don't forget the to the power of 2. How about the derivative of secant of x? Well, when you're going on this side, what I want you to do is actually to erase these two arrows. So the derivative of secant of x, you get secant of x, tan of x. Because here we see secant of x, then tan of x. Then the derivative of cosecant of x is equal to negative cosecant of x. So negative cosecant of x times cotangent of x. So this is a very neat trick. And don't worry, you will see why we need this in a second. Let's go ahead and erase everything except for this part. So let's erase everything. There's actually no direct way to solve the integral of cotangent to the power of 2, but there is an indirect way. So the indirect way is to convert the cotangent to the power of 2 to a cosecant. So if we look at our trigonometry identity and subtract both sides with 1, we have cotangent to the power of 2 is cosecant squared minus 1. And let's go ahead and split this integral apart. So we have the integral of cosecant to the power of 2 minus the integral of just 1 d theta. Now, 1 d theta, what is the antiderivative of this? Well, the antiderivative of this is just theta plus c. Since the derivative of cotangent is negative cosecant squared, then we know that the integral of cosecant squared is going to be negative cotangent c. It's like saying, well, you have the derivative of cosine, and that gives you negative sine. This means that if you do the integral of sine, so this means the integral of sine is going to be negative cosine. So the same logic applies here. And we're almost done. So remember the x equals 3 times sine of theta. This is where it comes in. From this, we know that sine is x over 3. And if you take a look at our triangle, this corner here is theta, then we have the SOHCAHTOA rule. So the SOH rule says that sine is equal to opposite over hypotenuse. And our opposite will be the x, and the hypotenuse will be the 3. So our opposite will be x, and our hypotenuse will be 3. We just need to find this side. The Pythagorean theorem says x squared plus b squared is equal to 3 squared. So this means b squared is 3 squared minus x squared, and 3 squared is 9. So b is equal to the square root of 9 minus x squared. Now you might be wondering, why is there no plus minus sign in here? Well, that's because the length of the triangle is always positive. That's why we only want the plus, we don't want the minus, and it's just redundant to write it at all. And let's replace the b with 9 minus x squared. Using this triangle, we can find the cotangent. So cotangent is equal to 1 over tan. And from the SOHCAHTOA, tan is opposite over adjacent. So opposite is x, the adjacent is the square root of 9 minus x squared. So this would be the square root of 9 minus x squared over x. And what is theta going to be? We know that sine is x over 3, so theta is arcsine of x over 3. And this right here is our antiderivative. The integral of 1 over x squared times the square root of x squared plus 4 dx. We see that there is the x squared plus 4. So let's go ahead and use trigonometry substitution. It's not the first form, but it is the second form. We can see that a squared is 4, so a will be 2. And we only want the positive integer. So x equals a times tangent, and a is 2, so we have 2 times tan. And we also need to find the derivative. So dx over d theta is equal to 2 times secant squared. Then we multiply both sides with d theta. We will have the integral of 1 over x squared. So x is 2 tan, and x squared would be 4 tan to the power of 2. So 4 tan to the power of 2 times the square root of x squared again. So x squared is 4 tan to the power of 2 plus 4 times dx. So times 2 secant squared d theta. I'm going to put x equals 2 times tan up here. Now let's solve the denominator. Let's simplify it first. We have 4 tan squared times the square root. 4 tan squared plus 4. Let's factor out the 4. So we have 4 times tan squared plus 1. And we know that tan squared plus 1 is secant squared. So let's go ahead and replace it. So what is the square root of 4 times secant squared? It's going to be 2 times secant. So this will be our new denominator. So the 2 here will cancel out with this 2. We have secant and secant squared, so they will also cancel out. We can move the 4 outside of the integral, so we have 1 over 4, the integral of 1 over tan to the power of 2. So 1 over tan to the power of 2, and this is basically the same as cosine squared over sine squared. Then we multiply by secant, and secant is basically 1 over cosine d theta. And as you can see, we have a cosine squared and a cosine, so they have to cancel out. We can also get rid of this because this is basically times 1. And we have to do u substitution. So let u equal to sine of theta. So du over d theta is going to be cosine. So du is cosine theta, d theta, and d theta is 1 over cosine du. This is equal to 1 over 4 times the integral of cosine over sine squared, and sine is u. So we have u squared times d theta, and d theta is 1 over cosine du. And the cosines will cancel out. So we have 1 over 4 times the integral of 1 over u squared. And let's go ahead and write it as u to the power of negative 2. So u to the power of negative 2, then we have du. This is equal to 1 over 4 times the antiderivative of u to the power of negative 2. And that's going to be u to the power of negative 1 over negative 1 plus c. So we have negative 1 over 4 times 1 over u plus c. So u is basically sine. So we have negative 1 over 4 times sine plus c. This is where our equation comes in. So x equals 2 times tan. So tan is x over 2. We have a right triangle, and here is our opposite side. Then using SOHCAHTOA, tan is opposite over adjacent. So the opposite side is x. The adjacent side is 2. And we want to find the hypotenuse. So c squared is equal to x squared plus 2 squared. So c is the square root of x squared plus 4. What is sine going to be? Well, sine is the opposite over hypotenuse, and opposite is x. Hypotenuse is the square root of x squared plus 4. Our integral will be equal to negative 1 over 4 times 1 over sine plus c. So 1 over sine would be the square root of x squared plus 4 over x. Using this, we have negative 1 over 4 times the square root of x squared plus 4 over x plus c. And let's write this as negative the square root of x squared plus 4 over 4x plus c. And this is our answer. The integral of x squared minus 1 to the power of negative 1.5 dx. So this is the same as 1 over x squared minus 1 to the power of 1.5 or 3 over 2 dx. Let's consider only the denominator, so x squared minus 1 to the power of 3 over 2. This is the same as x squared minus 1 to the power of 1 over 2 to the power of 3. And we can change this into the square root of x squared minus 1 to the power of 3. This is a trigonometric substitution problem, and we see we have the square root of x squared minus 1, which belongs to this form. So a, or rather a squared, is going to be equal to 1, so a is equal to 1. And we have x equals to a times secant, and a is 1, so 1 times secant is just secant. We also need the derivative, so dx over d theta. What is the derivative of secant? Well, it's going to be secant times tan. And we also need to multiply both sides with d theta. Now, the next step is to simplify this part. So we want to simplify x squared minus 1 inside the square root. So we have the square root of x squared minus 1, and that's equal to the square root of secant squared minus 1. And we also know one of the trigonometry identities, plus 1 is secant squared. When we subtract both sides with 1, we end up with tan squared is secant squared minus 1, which is this. And this will simply be tan of theta. We also need to replace dx, and dx is secant tan d theta. Here we have a tan, so the tan will cancel out with this, so the number will no longer be a 3, but it will be a 2. We have the integral of 1 over tan to the power of 2 times secant d theta. So this will be cosine to the power of 2 over sine to the power of 2, and secant is 1 over cosine. This cosine will cancel out with this. We have cosine over sine squared d theta. Now let u equal to sine. Du over d theta will be cosine. Du will be cosine d theta, and d theta will be 1 over cosine du. We substituted u with sine, so sine squared will be u squared. And what is d theta? Well, d theta is 1 over cosine. The two cosines will cancel out, and we have the integral of u to the power of negative 2 du. Let's go ahead and make some space. We have seen this integral many times, and this integral will give us negative 1 over u plus c. At the very beginning, we let x equals secant. We can also say that secant is equal to x over 1. It's the same thing. So secant is basically 1 over cosine, and 1 over cosine is x over 1. So x cosine is 1, and cosine is 1 over x. Our SOHCAHTOA rule says that cosine is our adjacent side over hypotenuse. So the 1 will be the adjacent side, and the x will be the hypotenuse. We just need to find this side. So a squared plus 1 squared is x squared. A squared would be x squared minus 1. So a will be square root of x squared minus 1. How about sine? Well, sine is opposite over hypotenuse, and this is opposite x squared minus 1 over hypotenuse, which is x. And here we have 1 over sine. So 1 over sine will simply be the reciprocal of this. So x over the square root of x squared minus 1. As a result, we have negative x over the square root of x squared minus 1 plus c. And this right here is the answer. The integral of the square root of 3 minus 7x squared dx. So we have the form a squared minus x squared, and x will be equal to a sine of theta. Now I can also rewrite this as a in parentheses to the power of 2 and x in parentheses to the power of 2. So looking at our integral, we have the integral of the square root of 3 to the power of 2 minus the square root of 7 times x to the power of 2. So this will give this. You can see they are the same thing. How about x equals a sine theta? Here we will have the square root of 7 times x is equal to a, which is the square root of 3 times sine. So it's not very difficult, is it? You have the square root of 3 over the square root of 7 times sine. How about the derivative dx over d theta? So the derivative of sine is cosine. We have the square root of 3 over the square root of 7 times cosine. And we multiply both sides with d theta. We have dx is equal to all of this times d theta. Just one thing to note is that the square root of 3 over the square root of 7 is the same as the square root of 3 over 7. Now, our integral would be 3 minus 7 times x squared. So x is this, and x squared will be the square root of 3 over 7 times sine to the power of 2, which will give us 3 over 7 sine to the power of 2 times dx, and dx is this, the square root of 3 over 7 times cosine d theta. Here the 7 will cancel out with this 7. So we have the integral of 3 minus 3 sine to the power of 2 times 3 over 7 in the square root cosine d theta. And let's go ahead and factor out the 3. So we have the integral of the square root of 3 times 1 minus sine to the power of 2 times the square root of 3 over 7 cosine d theta. Now, we know that cosine to the power of 2 plus sine squared is equal to 1. So cosine squared is 1 minus sine squared. This is basically this part. Now, the square root of 3 times cosine squared is just the square root of 3 times cosine. The square root of 3 over 7, as mentioned before, is just the square root of 3 over the square root of 7. So we have the square root of 3 times the square root of 3 is a 3. Then we have a square root of 7. And cosine times cosine is cosine squared. We should also move the 3 over the square root of 7 outside of the integral. Now, how can we solve this? You have to use one of the formulas. So cosine squared is equal to 1 over 2 times cosine times 2x. So the 2x is into parentheses plus 1. The other formula is sine squared is equal to 1 over 2 times 1 minus cosine. So here we will use this one. We have 3 over the square root of 7 times the integral of 1 over 2 times cosine 2 theta plus 1 d theta. We should bring the 2 outside of the integral. So we have 3 over 2 times the square root of 7, the integral of cosine 2 theta plus 1 d theta. And we also have to split this apart. So 3 over 2 times the square root of 7 times the integral of cosine 2 theta d theta plus the integral of 1 d theta. We can use u substitution to solve for the integral of cosine 2 theta d theta. So let u equal to 2 theta. The derivative du over d theta is just 2. So du is 2 d theta, and d theta is 1 over 2 du. We have the integral of cosine, and 2 theta is simply a u. Then d theta is 1 over 2 du. So we have 1 over 2 times cosine of u du, and we have 1 over 2 times sine of u plus c. And u is 2 theta, so we have 1 over 2 sine 2 theta plus c. And how about the integral of 1 d theta? Well, the antiderivative of this is just theta itself. Now we have 3 over 2 times the square root of 7 times 1 over 2 sine of 2 theta plus 3 over 2 times the square root of 7 times theta plus c. So this would be 3 over 4 times the square root of 7 sine of 2 theta plus 3 over 2 times the square root of 7 times theta plus c. Now, what is sine of 2 theta? Sine of 2 theta is basically 2 times sine of theta cosine of theta. And we have the 2 and the 4, so they have to cancel out. 3 over 2 times the square root of 7 times sine of theta and cosine of theta plus 3 over 2 times the square root of 7 times theta plus c. X equals the square root of 3 over the square root of 7 times sine. So sine is going to be the square root of 7 over the square root of 3 times x. Now we can use that to our advantage. So let's draw the triangle. Then sine is opposite over hypotenuse. So the opposite is the square root of 7 times x, and the hypotenuse is the square root of 3. We have sine, so we just need to find cosine. Now cosine is adjacent over hypotenuse, so we need to find adjacent first. Let's call this b. So the square root of 7x to the power of 2 plus b squared is the square root of 3 to the power of 2. This right here is 7x squared plus b squared is 3. Is 3 minus 7x squared, and we have the square root. So b is 3 minus 7x squared. As a result, cosine is the square root of 3 minus 7x squared over hypotenuse, which is just the square root of 3. This will give us 3 over 2 times the square root of 7 times sine. And sine is the square root of 7 over the square root of 3 times x. And cosine is just the square root of 3 minus 7x squared over the square root of 3 plus all of this. So 3 over 2 square root of 7 theta plus c. Here the square root of 7 will cancel out. We have 3 over 2 times, here we have x over the square root of 3 times the square root of 3 minus 7x squared over the square root of 3 plus 3 over 2 the square root of 7 the theta plus c. We have the square root of 3 times the square root of 3 is a 3. So the 3 will cancel out with this 3. We have x times the square root of 3 minus 7x squared over 2 plus 3 over 2 the square root of 7 times theta plus c. The last thing we need to find is just theta. So x is the square root of 3 over the square root of 7 and times sine. So sine is just the square root of 7 over the square root of 3 times x. So theta will be arcsine of the square root of 7 over 3 times x. We just substituted arcsine with theta, and finally don't forget the plus c. So I know that's a lot, but this here is our answer. The integral of the square root of x squared minus 2x dx. So this right here is a trigonometric substitution problem, but as you can see, this doesn't fit into any of the forms. But there's a trick. So we know that x squared minus 2x, we can say plus 1 minus 1. So it's the same thing as plus 0. And then we have x minus 1 squared minus 1. And then we can turn this into a u, and that will allow us to get one of these forms. So let's go ahead and do that. We have the integral of x minus 1 to the power of 2 minus 1 dx. Then let u equal to x minus 1. We have the integral of the square root of u squared minus 1 dx. And we have to convert the dx into the du by doing the derivative. So du over dx is equal to 1. So du is equal to dx. In these three forms, we can see that x is the variable and a is the constant. So same thing here, we have u as the variable, u squared minus 1, and 1 is a squared. So we have u equals a secant theta. So obviously it belongs to this form. And this is what we have. And in the square root, we can see that a squared is 1. So a is 1, and u is equal to a times secant, which is 1 times secant, and we can just write it as secant. What is the derivative of secant? The derivative is going to be secant tan. And we need to multiply both sides with d theta to get du. So we have du is equal to all of this times d theta. So I put all of the important pieces of information here, and we will reuse this later on. And this integral is equal to u squared, and u is secant. So we have secant squared minus 1, and du. du is secant tan. Secant tan d theta. We know that tan squared plus 1 is secant squared. So if we subtract both sides with 1, we get tan squared is secant squared minus 1, which is basically this part. So we can replace this with tan squared. This is equal to the integral, and the square root of tan squared is just tan, times secant times tan d theta. So tan times tan gives you tan squared again. What we can do here is convert all the tan into the secant, so it's easier for us. Let me show you. We have the integral of tan squared, and remember tan squared is secant squared minus 1 times secant d theta. So this is equal to secant to the power of 3 minus secant times d theta. The next step is to split the integral apart. So we have secant to the power of 3 d theta minus the integral of secant itself. So I've made separate videos to explain the integral of secant and the integral of secant to the power of 3. You can refer to those ones if you want, but here are the formulas. So continuing on, the integral of secant to the power of 3, that's this part here. And we're just going to multiply 1 over 2 with these terms. So we have 1 over 2 times secant times tan plus 1 over 2 times the ln of the absolute value of secant plus tan. We finished this part. Now we have to minus this part. So minus the antiderivative of secant is the ln of the absolute value of secant plus tan. Now as you can see, both of these are the same. They are the same term. So we can simplify this. We have 1 over 2 of this minus this part, which gives us negative 1 over 2 of ln of secant plus tan. And then don't forget our initial part, which is 1 over 2 times secant times tan. And then plus c. This is where our initial assumptions come in. So u is equal to secant, which is u is equal to 1 over cosine, because 1 over cosine is secant. Then we have u times cosine is equal to 1, and cosine is 1 over u. Using the SOHCAHTOA rule, we can see that cosine is adjacent over hypotenuse. So the adjacent side is 1, and the hypotenuse is the u. We need to find this side. So let's call this side a. According to the Pythagorean theorem, a squared plus 1 squared is equal to u squared. So a squared is u squared minus 1, and a is the square root of u squared minus 1. If we look at our antiderivative, so here's our antiderivative. We already know what secant is, because secant is just u. The only thing we need to know is what is tangent. So tangent is equal to opposite over adjacent. So the opposite side is u squared minus 1, and the adjacent side is 1. So divided by 1. And since it's divided by 1, we do not need to write that. So we have 1 over 2 times secant, and secant is just u. So times u, and times tan. And tan is the square root of u squared minus 1. And then minus 1 over 2 times the ln of absolute value of secant, and secant is just u, plus tangent, and tangent is the square root of u squared minus 1 plus c. The last step is to convert the u back into the x, because our original integral is in terms of x. So we have 1 over 2 times u. And what is u? Well, u is x minus 1. So times x minus 1 times the square root of u squared, which is x minus 1 to the power of 2, then minus 1. And then we also have to subtract 1 over 2 times ln. Let's write it down here. So minus 1 over 2 times the ln of the absolute value. Now let's go ahead and convert all the u's to the x in here. And plus c. So this right here is our answer.